In this video, we're going to use the factor theorem to build a polynomial. So we're going to write the polynomial f of x of degree 3 that has the zeros of 1/2, radical 6, and negative radical 6, each with a multiplicity of 1. So by the factor theorem, if 1/2, the square root of 6, and negative square root of 6 are zeros of the polynomial f of x, then we can say that x minus 1/2 and x minus radical 6 and x plus radical 6 are factors of f of x. Therefore, we're able to say that f of x equals the multiplication of those factors. So we can take that, and if we go ahead and we notice here that these are conjugates, and when we multiply conjugates, we can take the a squared minus the b squared, given that our x is the a and the radical 6 is our b. So we'd have x squared minus radical 6 squared, and we would be able to cross out our square root and our square, leaving us with x squared minus 6, which leaves us now with x minus 1/2 times x squared minus 6. And now we're going to head and we're going to distribute these factors, and some might even call it foiling. And so we will take x times x squared and get x to the third, and take x times negative 6 and get a negative 6x. Negative 1/2 times x squared is going to be a negative 1/2 x squared. And then negative 1/2 times negative 6 gives us a positive 3. So we can see here that then f of x can then be written as x to the third minus 1/2 x squared minus 6x plus 3. And now we have a polynomial f of x of degree 3 that has the zeros of 1/2, radical 6, and negative radical 6, each with a multiplicity of 1. Now what's important is that this f of x is not unique. If we were to multiply f of x by any non-zero constant a, so that we had something that looked like this, f of x equals, we took some a value and multiplied it by our x to the third minus 1/2 x squared minus 6x plus 3, that the polynomial would still have the desired factors and zeros. So a could be any non-zero number. For example, let's say that we let a be the number 2. So if we plugged in a 2 right here, and multiply that by x to the third minus 1/2 x squared minus 6x plus 3, then we would end up with an answer of f of x equals a 2x to the third minus x squared minus 12x plus 6. And that would also be a polynomial of degree 3 that has the zeros of 1/2, radical 6, and negative radical 6. So you've got to be careful there, because you can have many solutions. So here we have our answer, but this is also an answer. So hence we see we have many solutions. Let's take a look at the graph of this so we can see it a little bit better. So if we take a look at the graph, scoot it over, here we can see our original equation. Here's our first one that we did, and we can see our where we multiplied by a. And notice that in this situation, the graphs have the same x-intercepts and differ only by a vertical stretch. And so that's how you can use the factor theorem to build a polynomial